Hi there, I'm Professor E.
I'm DJ Schurz.
And welcome to the Robot Program. In this episode, we're going to show you how your AdventureBot can follow a line. How are we going to do that?
We're going to do that using blue painter's tape. Now, of course, you can use green painter's tape as well, and we just choose to use blue.
Okay, so different color than your floor.
Different color than your floor.
Okay.
Yes. And we also are going to use 2 additional easy bit clips, cubes, that will connect to the front of the robot, which we'll attach the camera to.
So we have to modify AdventureBot before we get started.
That's right. So let's do that right now. So we'll disconnect the camera from the top of the dome. So we'll slide that out and take the dome off the top of the robot. And then we're going to attach our cubes to the front. And then we are going to attach our camera facing down like that.
So now the camera is facing the floor so you can see what he's going to drive over.
Yeah, and we can demonstrate that by putting a piece here. And you can see that the robot is going to drive.
Perfect. So if his camera was still facing forward, he wouldn't be able to see the line.
Yeah, you got it.
Kind of important.
Yes. So we have to make a track for the robot to drive along.
Okay, let's make a track.
Let's do it.
Okay, so we have our maze ready to go. So we don't want any straight lines. We want to see if our AdventureBot can go around corners.
That's right. And at the same time, we don't want the curves to be too drastic. Otherwise, the camera, which is looking down, he's going to miss the angle, and he's not going to be able to follow it. So you'll be able to experiment at home or in the classroom and find different combinations of corners that work for you. We now have to load up Easy Builder and configure AdventureBot to follow the blue line. So the first thing we're going to do is we're going to load up our software here, Easy Builder, and skip going to school. We'll turn our AdventureBot on. And we will connect to the AdventureBot's Wi-Fi network. Now, we are going to use the AdventureBot Bear project. So we're going to choose the example projects.
And this is just a nice clean workspace where you don't have to worry about other controls and you can just add what you're going to need.
And we'll choose AdventureBot Bear. And now we'll push the connect button. So we should be able to click in this area here and drive the robot. Great, so we know it's working. Now what we're going to want to do is we're going to want to click in the servo movement panel and choose use the stop value. And if you've calibrated your servos, if I push test on the stop value, the robot should not move. And if I put test on the other one, the robot should not move as well. If the robot does move, then simply uncheck test and uncheck use and click test again. So we're going to keep the use button on. Now, if your robot is moving, you're going to want to calibrate your servos and, of course, check the calibration tutorial.
So we want to make sure he's not moving right now, nice and still.
So we'll choose save now that we have use selected. And now what we're going to do is we're going to add the camera control. So project, add, camera, camera device, and push the start button. Now we can see what the robot is seeing.
So he's looking down.
He's looking at Andreas. Yes, so he is looking down. Okay, now because he's looking down, let's put the robot down on the track so we can calibrate his camera to recognize the color blue. So we're going to do that. You can see in the screen, like the color blue is in the center here. So we're going to choose the multicolor and edit the first multicolor. Now here's a color wheel that we get to use to filter just the color that we care about. So you see as I move it past blue, it starts to disappear. That's because we're telling it to disregard that particular color. We actually want only to see the color blue. So we're going to back this up just until the color blue, or green, if in this case you're using green painter's tape, is visible. We'll do the same with the other end. And when it starts to disappear, we're going to back it up again. There we go. Now, we have saturation values here. This is going to make a filter for the minimal and maximum saturation values. So we're going to do the same thing. We're going to increase the saturation until it starts to disappear, and back it off again.
So we're trying to make it as accurate as possible, because if you have too wide a range, the robot is going to recognize colors other than what you want it to.
That's correct. A white and blue may actually be the same because white might have a little bit of blue in it, but to your eyes it might not. So that's going to be the luminance. But right now we're going to do the saturation. We're going to lower the maximum saturation until just right there, back it off a bit. Now luminance will do the same thing. We'll increase it, back it off. Now the maximum, we'll decrease it, back it off. There we go. So now we just see the color blue that we're looking for. So we can push save. Okay, now we want to tell the robot to follow the color blue when it sees it.
That particular color that we just saved.
It's right. And we want to be able to tell it where on the screen that color blue is going to be followed. So we're going to click on the grid tab now. And you see these slide dials. When I move the slide dials, you see how they're moving the quadrants? Well, I'm going to move the top quadrant to the top, the bottom quadrant all the way to the bottom, and the left quadrant here, I'm going to move that all the way to the right, to the center, and the right quadrant, I'm going to move that all the way into the center as well.
So all we've done is narrow down where it's looking. We're giving it just 2 fields.
That's right. But the robot doesn't know that it should actually follow its movement yet. It just knows where the object is going to be. And we can experiment with that by just choosing tracking and clicking on multicolor. And you can see it's highlighting now where it actually sees the track.
So it can detect blue, but it doesn't know it has to go towards blue yet.
That's right. So we're going to deselect the multicolor now, and we're going to go into the button to configure the camera device. And in here we have 2 different options to have the robot track a particular object. We have servo tracking and movement tracking. We're going to use movement tracking in this case. So we're going to select the movement tracking checkbox, and we want to have use speed settings selected. And the speed settings we're going to use for AdventureBot are, we'll bring this guy down all the way to 20. And then we'll right click on the right one and bring this one down all the way to 30. Now what this is going to do is specify how fast the robot needs to move forward. We can test this by pushing the test button. Your robot should now be moving perfectly forward. Once you verify that, push the stop button. If your robot isn't moving forward, then tweak these forward values just a little bit until your robot is moving forward with the test button. Now we're going to do the same with turn left. So the speed to turn left, we don't want to turn the speed at 255 because the robot will turn really fast. Should we try that out to see?
Let's see it.
Way too fast.
And if he's going too fast, he's not going to be able to recognize the path that's in front of him, and he might get off the path.
So we want to slow the speed down for turning. Now the speed I like to use for turning left is around 24, 25. Now the speed to turn right, I'm going to set that for a speed of 20. So let's try turning left. We'll push the left test button. And now we'll try pushing the right button. Okay, now right is a little quicker than left. So let's slow right down by 1 and go to 19. That looks like they're both the same speed.
Looks pretty good. Now these are values that specifically work with your AdventureBot. So you might have to tweak yours a little bit in either direction.
You got it. Okay, next we want dynamic speed when turning. What that's going to do is when the robot is seeing the object in front of it, or in this case below it, it's going to turn more based upon how far away it is on the screen. So if the object is too far to the right, it's going to turn quicker. If the object is in the center, it's going to turn just a very slight amount. So you're going to get this slight little sway rather than the robot stopping, turning, moving, stopping, turning, moving. Okay? So we'll turn that checkbox on. Now, I'm going to test the slowest speed for left, bring it all the way down to 1. That's a good speed for me. And for right, let's try 10. That's a great speed as well. All right, so now we're going to check the save button.
So now because you've changed the speed settings, it's going to use those speed settings and not the one in the servo movement panel.
You got it. So as soon as it recognizes an object, it's going to use those settings to track that particular object. So now what we're going to do is we're going to put the robot centered up on the line.
Okay, so we can see the path.
Now I'm going to choose multicolor. And if all works and configured correctly, the robot will track and follow the line.
So if we take a look at the camera preview, we can actually see where he's tracking that blue. And then you can see how fast or slow he's going towards it, depending on how far it is on the screen. So sometimes it's really far off, sometimes it's in the middle, and he's catching up to it.
And you can see that on the screen, the floor is spinning by really fast. You can see, it looks like the robot is driving at 100 miles an hour. But on the camera, you can see it's driving very slow. That's because the camera is so close to the ground that it looks like it's driving quickly. If you wanted to increase the robot's speed, you'd have to raise the camera further away from the ground to get more view so it understands and can predict where the corners are going to be in the future.
So wider field of view.
That's right.
Good.
So the reason why AdventureBot is moving so slow for this example is because the camera is very close to the ground.
Need some more easy bits.
You need some more easy bits.
Stack his neck up higher.
Extend it up. You can also get a camera extension cable, so you can bring it all the way up, maybe 2 or 3 feet if you really wanted to.
Like a little dinosaur with a long neck.
Yes. So it's very soothing watching him go around. And of course,
he's concentrating very hard.
Yes, he is.
In this episode, we showed you how your AdventureBot can track a colored line on the floor. To create your own track, you'll want to put down some sort of a tape or line that is a different color than your floor. You'll also need to modify your AdventureBot so that the camera is pointed down towards the floor. You can do this using extra EasyBit extension cubes. The camera height will dictate the field of vision. If your track has too many sharp angles or curves, the robot may not be able to detect the changes within its field of view. Load Easy Builder and bring up the Bear project for AdventureBot. The Bear project provides a nice clean workspace without any extra controls. This allows you the freedom to add only the controls you need for this activity. Connect to your AdventureBot and then click on the gear icon in the servo movement panel. Click on the Use checkbox beside the stop values. When you click Test, your AdventureBot should not move. If it does move, go back to the calibration episode and recalibrate your servos. Add the camera device from the project controls and click on Start to start the camera. In the camera preview, make sure that the robot is looking at the color you want it to detect. You're going to click on the Multicolor tab, and there you'll see a color wheel that allows you to filter out all the other colors except for the one that you want. The more narrow the range of color, the more accurate your detection will be. You want to move the slider until you can no longer see the color that you want, and then slowly bring it back into view. Again, this allows us to narrow that range so it's nice and precise. Back in the camera control, you're going to click on the Grid tab. Now we need to tell the robot to have 2 different decision-making paths, move left or move right. And we're going to start this by moving the grid so that there's only one line down the middle. So you're going to move the sliders and you're going to bring the left line into the middle, the right line into the middle, and move the horizontal lines off of the grid. When the color enters the left side of the grid, the robot will now know to move to the left. When a color moves into the right side, the robot will know to move to the right. Click on the gear icon in the camera device to access the configuration settings. Select the movement tracking text box and click on Use Speed Settings. You can now change the right and left settings for your robot. Remember that if a robot is moving too quickly, it may not be able to detect the changes in the path. Adjust the left and right settings to the desired speed for your robot. You can test the values for straight movement, right and left turning before moving on. Lastly, click on the checkbox that says Dynamic Speed while turning. This will tell the robot that if the color is detected further away, it should move faster towards that color. And if the color is detected closer to the robot, it will move more slowly. This helps create a nice, smooth path following rather than it being abrupt changes. When you save, the robot will now use these speed values instead of the settings in the servo movement panel. Return to the Tracking tab and click Multicolor to start tracking. Your AdventureBot should now be following the path according to the color that it sees. Thanks for watching this episode, and we'll see you next time. Why are multiple filters applied to the desired color? Changing the grid provides how many decision-making options? How does enabling dynamic speed when turning change the robot's movement? Find the answers at therobotprogram.com.